Module 2, Fractions and Decimals. This is section 2.5, Adding and Subtracting Unlike Fractions. When you're adding or subtracting unlike fractions, you will first need to find a least common multiple. That way you can have a common denominator. Each fraction has to be an equivalent fraction whose denominator is the least common denominator. Then you're going to add or subtract the like fractions, again only in the numerators. And then if you can, you're going to reduce to simplest form. For example, I wanted to add 2/5 and 8/15. The least common denominator is a 15. Since I know that 5 times 3 is 15, and then this one already is a 15, so I don't need to change it. Since I would be multiplying the 5 times a 3, I would need to also multiply the numerator over 2 times a 3. So an equivalent fraction of 2/5 would be 6/15. I could easily simplify 6/15 down to 2/5. So I'm going to take out the 2/5 and put in its equivalent fraction of 6/15. Now that my denominator is the same in both fractions, I can just do the operation in the numerator. And 6 plus 18 is 14. Since this can't be reduced any further, my answer is already in simplest form, and the answer is 14/15. Let's look at two examples. If I have 2/3 plus 1/8, my least common denominator would actually be the 3 times the 8, which is 24. This will always work. You can multiply the two denominators to get a common multiple. It may not be the smallest least common multiple, but it will definitely be a common multiple. So I'll need to multiply both of these parts of my fraction by an 8 to get 16/24. And over here I'd have to multiply by a 3 on both parts to get 3/24. Now that my denominators match, I have a common denominator, I'll keep that same denominator the whole way through and just add the numerators. So my answer is 19/24. It's the same thing for subtraction. I need a least common multiple for 11 and 3. You can multiply the two together to use a 33, which actually happens to be the least common multiple, or you can look at your multiplication list and see which number repeats in both columns. If I want the 11 to be a 33, I would need to multiply by a 3. Whatever I do to the bottom, I have to do to the top. So now I have 30/33. To get a 3 to be a 33, I'll need to multiply by an 11. If I multiply by 11 in the denominator, I'll need to do that in the numerator as well. And so I have 22. Now that my denominators match, I'll keep that for my final answer and say 30 minus 22, which is 8. Again, this is my already in simplest form, so I am finished, and that is my final answer. Let's look at letter B, and then after we're done with letter B, see if you can find A, D, and E. My least common multiple for letter B is going to be a 25. To change a -1/5 to a fraction that has a 25 in my denominator, I would need to multiply by a 5. 5 times 5 is 25, and whatever I do to the bottom, I also need to do the top. So that would be a -5 up top. My other fraction already has a denominator of a 25, so I could just bring this over as a -2. Now that my denominators are the same, I'll keep that the whole way through, and a -5 plus a -2 is a -7. Remember, when you're adding side numbers, if the signs match, you add the absolute values and keep the same sign. Pause the video and see if you can find A, D, and E. Alright, my least common multiple for A is a 10. This already is a 10, so all I need to do is multiply the 5 by a 2 to get a 10, which means I need to multiply by a 2 up top as well and get 4. When I add, I get 5/10. I can reduce this by dividing each one of these by a 5, since 5 is 5 times 1, and then my denominator is 5 times 2. The 5s will be the equivalent of a 1, and I'm left with a 1/2. For D, my common denominator, my least common multiple, is a 20. You could use a 100, though. It's not the smallest one that you can use, but it's one that you could use. To turn a 5 into a 20, I would need to multiply by a 4. Since I need to multiply by a 4 on the bottom, I'll need to do that up top as well. So now I have 12 over 20. The other already was 20, so now I could just go ahead and add my numerators for 13 over 20. E, I have the same least common multiple over 20, except now when I multiply by a 4 up on my top, I'll have a 16. The other already had a denominator of 20, so now I could just subtract 13 over 20. And they're both in least common, the most simplest form, so we're all done. Let's look at a word problem. I have a truck that has a 1/4 of a ton of computers, right? 1/4 of a ton of computers, 1/3 of a ton of televisions, and 3/8 of a ton of small appliances. Let's find the total weight. To find the total weight, I'll need to add up all of the weights. With all three fractions, I'll need to get a common denominator that all the numbers could be. So 4 could be an 8, but 3 couldn't. A 4 and 3 could both be a 12, but an 8 can't. So I'm going to have to go a little bit further, and it turns out 24 is going to be the smallest one. To turn my 4 into a 24, I would need to multiply by a 6, so I'll need to multiply by a 6 up top. To turn a 3 into a 24, I'll have to multiply by 8, so an 8 up top. To turn the 8 into a 24, I'd have to multiply by a 3, so 3 up top. Now that I have my common denominator of a 24, I'll just do my operation up on the top. 6 times 8 is 14, plus 9 more is 23. The total weight is 23 over 24, just short of a full ton. We can also use common denominators to compare fractions. So if I wanted to use less than or greater than to compare 3/8 and 14 over 40, I would want to change the denominators to be the same number. I can turn an 8 into a 40 by multiplying by a 5. And so now I can compare 15 over 40 to the 14 over 40. These are the same, so I just need to compare the top part of the fraction, and 15 is greater than 14. So 15 over 40 was represented by representing the 3/8, so 3/8 is greater than 14 over 40. Let's compare -2/7 and a -1/3. The least common multiple here is a 21. To turn a 7 into a 21, I'll need to multiply by a 3. So same thing up top, and I have a -6 over 21. For the other side, I'll have to multiply by a 7 to get a 21, so a 7 up top, and I have -7. Now remember, negative numbers count backwards, so the smaller the number looks, the bigger it actually is. So -6 over 21 is actually bigger than -7 over 21. You can also use fractions when you're evaluating expressions. So I have x plus y. If I want to find x plus y for x is a 1/3 and y is a 4/5, I would replace the x with a 1/3 and the y with the -4/5. Then I would find a common denominator. Common denominator is a 15, so I need to multiply by a 5 for the 1/3 and by a 3 with a -4/5. This turns my expression into 5/15 plus a -12/15. When you're adding numbers that have opposite signs, you find the difference. The difference between 12 and 5 is 7. And then take the sign of the one with the larger absolute value. That's the 12. So my answer here is a -7/15. Let's do the same thing with a 1/4 and a -3/5. 1/4 plus a -3/5 would need a common denominator of a 20. To make a 4 into a 20, I would need to multiply by a 5. And so I'll multiply by a 5 up top. 5 times 4 is 20, so -3 times a 4 is a -12. Now I have my common denominator of a 20. The difference between 5 and 12 is still 7, and so I have a negative 7 over 20. For b, I want to multiply. Multiplication is a little bit easier. 1/4 times a negative 3/5 does not require a common denominator. All I do is multiply numerator times numerator and denominator times denominator. See if you can find C and D. Pause the video and then check your answers. For C, I have 1/4 minus a negative 3/5. This one's a little tricky. While my fractions will still be 5 over 20 and negative 12 over 20, when you're subtracting numbers that are opposite signs, you're actually going to add the opposite. So this will stay a positive, this will turn to addition, and this will turn to a positive. So I'm talking about 17 over 20. For D, when you divide fractions, so 1/4 divided by a negative 3/5, you turn it to multiplication. So this would be 1/4. Division becomes multiplication. Take the reciprocal of the second number. I have a 5 over a negative 12. And if you leave the negative up top and have a negative 5 over 12, that's fine also. That's how you use common denominators to compare fractions and to add and subtract fractions.